Hey, welcome back to Algebra 2. Today we're looking at section 10.3, which is solving for quadratics, where the solutions could either be, real or complex. In the past, we used to solve quadratics and everything came out to be real solutions because, that's how it was when it was first introduced. But if you think about how the quadratic formula works, your answer could also be imaginary or slash complex because what's inside the square root could be negative. So that's what we're going to look at for today then. So here we have a few problems that I've set up and we can look at it together and we'll go ahead and solve them together and hopefully everything will work out. In the first one, we have number one, -5 is equal to -2 x squared and then plus 3x. Give me 1 second. I am setting up my plan. Yes, so there it is. Okay, so first things first, we're going to go ahead and move everything to one side. So then we have a quadratic formula set up. So we're going to move everything over to the right hand side in this case. 0 is equal to -2x squared and then plus 3x and then we have plus 5. Now, according to the quadratic formula, and if you need me to, I'll go ahead and write it down on the side. X is equal to -b plus or minus the square root of b squared minus 4ac all divided by 2a. So hopefully by now you have somewhat memorized this. So going piece by piece, a is going to be -2, b is going to be 3, and then c is going to be 5. So that means according to the quadratic formula, x is then equal to -3 and plus or minus the square root of 3 squared, which I'm going to write as 9, minus 4 multiplied by a multiplied by c. And then all divided by 2a. 2 multiplied by -2 in this case. All right, so if we clean up our math a little bit more. Oh, actually, I see a mistake. This is supposed to be a -2, so that's going to make things positive then. So cleaning up a little bit more, we have still the -3 plus or minus the square root of 9 and then plus 4 times 2 times 5. So that's going to equal to 40 and then plus the 9. So that's a perfectly nice 49 that we're looking at, all divided by -4 on the bottom. And because we have the square root of -49, then that comes out to be nice and clean in this case. So our answers are going to be -3 plus or minus 7, all divided by -4. And I guess if you want to, look at each one individually, then that means one answer is x is equal to -3 plus 7 divided by -4. And if we add those two together, that is going to give you positive 4 over 4 negative, which is equal to -1. And for the other answer, x is equal to -3 and then minus 7 divided by -4. So that's going to give you -10 over -4, or you can say 2.5 or 5 over 2. So those are going to be your two solution sets. Sometimes it's okay to leave your answers like this. That really depends on the teacher. But, for me, if you can go further, go ahead and go further. Now, for the second one, we'll do exactly the same. And this is the time where your solution, I'm going to tell you, is going to be imaginary. Not necessarily because the way that it's formatted, but, it's because I wrote it this way. So, once again, same idea. We're going to put everything all into one side, and then we're going to go ahead and solve then. So, let's say this time I'm going to move it all over to the left-hand side, giving you 9x squared, and then plus 3x plus 4 is equal to 0. Now, if you want to check if something is going to be imaginary or not, you could technically use the discriminant, if you remember that, which is the square root of b squared minus 4ac. And if that number is positive or negative or 0, that will tell you what kind of solution you actually have. But since we're going to solve, we might as well just go ahead and jump straight into it then. So once again, according to the quadratic formula, x is equal to -3 plus or minus the square root of 3 squared, which will give you 9, minus 4 multiplied by a, which is equal to 9 again, and then multiplied by c, which is equal to 4, and all divided by 2 times 9. Now, let's go ahead and show a little bit of a trick in this case because I don't have a calculator and I don't want to multiply everything up. So, using a little bit of algebra, we can actually simplify this without having to, overthink it. -3 plus or minus the square root of, and this does not work all the time, but I like to think that it works like sometimes, and if we can take advantage of it, go ahead and do so. You'll notice that each term there is something in common, and that something is actually going to be 9. So what I'm going to do is I'm going to go ahead and factor out the 9 that they have in common, and that will leave us with 1 minus 4 times 4, which is going to be 16. So notice the 4 multiplied by 4, and that's where the 16 is actually coming from. And that's kind of nice because look, those are numbers that are just multiplied together, so they're actually kind of nice and clean. You can multiply out the bottom again if you want. I can go ahead and do so, I guess, just to make it a little bit easier. But now, once again, if we look at top, that's -3 plus or minus the square root of square root of 9. Well, square root of 9 is square root of 9. And then inside over here, we have -15. And right there, that's the imaginary part, right? So now we'll go ahead and clean up a little bit more. -3 plus or minus the square root of 9, that gives you 3. Multiplied by the square root of 15 negative, which I'm going to actually write as the following then. I'm going to write it as square root of 15, and the negative, I'm going to go ahead and write that as I then, as a result. Because if you recall from the last section, I is supposed to be equal to the square root of -1. So that's where the I part comes in. All divided by 18. And finally, because every single term is divisible by 3, we're going to go ahead and do so. So our final answer is -1 plus or minus I multiplied by the square root of 15, and then all divided by 6. And unfortunately, we can't go any further, so we'll go ahead and leave the answer as such. For number 3, same thing. If you want to go ahead and try this, pause the video and try it on your own, and then afterwards we'll compare answers. But if not, we're just going to go ahead and then. So I'll just assume that, you try it on your own and you've paused it, and I'm going to go straight into it now. Okay, let's move everything over to the right-hand side because, I'm trying to keep everything positive if possible. So let's see. Let's try to use a different color pen just to make this a little bit more different. What's a good color? Let's go ahead and use maybe this fuchsia, I guess. I don't know what that color is. Move everything to the right. So 3x squared and then plus 2x squared. That's a total of 5x squared. We have 4x, and you're going to subtract 6x. So that's going to be minus 2x. And then we also have the plus 2. All that is equal to 0. So quadratic formula, x is equal to 2 plus or minus the square root of 4 minus, because 4 is equal to 2 squared, -2 squared, multiplied by 4 times a multiplied by c. And again, if you want to go ahead and do that magic algebra trick that I did on the right, that's totally fine. If you want to multiply out the numbers on inside the square root, that's totally fine too. From what I'm seeing, that does come out to be negative, so that means we're going to have an imaginary as well. So 2 plus or minus the square root of, they all have 4 in common. I'm going to go ahead and factor that out. The first term, factor out 4, you have 1 minus 4 factor out from the second term. That leaves us with 5 times 2, which is going to be 10. All divided by 10 on the bottom. So once again, that's where your imaginary part comes in. We have 2 plus or minus the square root of 4 multiplied by -9, all over 10. And if we clean that up, you have 2 plus or minus, square root of 4 is 2. Square root of -9, that is going to be 3i, and then all divided by 10. Final item, divide everything by 2 because that's what's in common. So 1 plus or minus 3i all divided by 5 is going to be our final answer then. All right, so hopefully, that is pretty straightforward. Now what we're going to do is work backwards, meaning if you are given the solutions, I want you to work backward to figure out what is the quadratic that will give you those solutions. Anytime when it comes to math, remember, if you need to go forward, you're going to have to learn how to go backward too, and this is basically it. So here we have following examples. Let's say that the quadratic yields the solution of 6 and -2/3. Now, if we're working backwards, I think the best way for us to think about this is we can say that x minus 6 is going to be one solution, or not one solution. X minus 6 is going to be one factor, and then we'll also have x plus 2/3 is going to be equal to the other factor, and all of that multiplied together is equal to 0. So generally, that's how quadratic works, because we factor this, and then afterward, whatever the factor is, we set it equal to 0 to solve for x then. So you definitely will be able to get those as such. Are we done here? The answer is, technically we are, but, since most likely we need to multiply everything out to make it looks like the form of ax squared plus bx plus c, we might as well just go ahead and take it one step further. First thing I want to do is I'm going to go ahead and take this guy right here, and I'm going to multiply everything by 3. And the reason for that is, if you notice the second term right here, right, we have a fraction, which, I don't mind it, but I prefer if a, b, and c are integers. So that's why I want to look at it that way. So if we multiply 3 to both sides of the equation, we're going to get x minus 6, and then we're going to multiply the 3 into the second part, so that's 3x plus 2, and all that is still equal to 0 because 0 times anything is always equal to 0. And now I like that a lot better because when we multiply everything out, we're going to get our standard form of the quadratic then. So a little bit of multiplying using FOIL. So first part is 3x squared, and then we have plus, let's see, 2x over here, and then we have minus 18x, and then finally minus 12 is equal to 0. And finally combine your like terms, so 3x squared minus 16x and then minus 12 is equal to 0, and that's going to be our quadratic then. For that second one, which is the same idea, but now this time I'm giving you the following. I'm saying that, hey, the solution is complex. It is going to be 5 minus 4i. Well, isn't there usually two solutions? Because, it is quadratic, it comes in pairs, right? And your answer is, it is not wrong. You do actually have a second pair. Now, you can actually find out what the second pair is because anytime you solve for quadratic, right, especially when it comes out to be these, what's that called, complex solutions, you'll notice that it's 1 plus or minus 3i divided by 5, or 1 plus or minus I root 15 over 6. So what I'm saying is that, yes, if they give you one solution, you technically know the other one. The other one is supposed to be the conjugate, which is 5 plus 4i, right? Because it's supposed to be 5 plus or minus 4i as your solutions. So that's kind of like the cryptic part. It's hidden in there. Now, I'm going to go ahead and solve for this going backwards, just like we did with number 1. We're going to go ahead and say the following. X minus, in parentheses, 5 minus 4i, because that's going to be my first factor according to the first given solution, multiply by x minus, in parentheses, 5 plus 4i, because that is supposed to be the other solution, and all of that is multiplied equal to 0. Your job, once again, is to multiply that out and give you something that is quadratic that's on the bottom. Well, you can multiply it out by using a 3 by 3 and then, lattice your way through it. But if you look carefully, there's something that'll tell you you can do this a lot faster. Let's multiply the inside out and you'll see what I mean. First, we have x minus 5 and then we have plus 4i. Second, we have x minus 5 and then we have minus 4i. All of that, once again, is equal to 0. If you look carefully, you'll notice that we actually have a conjugate pair, a plus b times a minus b. And when we look at it that way, a plus b multiplied by a minus b, we know that that's supposed to give us a squared minus b squared. So without having to do a lot of excess work, this is supposed to give me the following then, according to difference of square. A, which is x minus 5 squared, right, because it's a squared, minus b squared, which is 4i, and then the whole thing is going to equal to squared, and it's also equal to 0. That is a lot cleaner then, and it's going to save you a little bit of time when it comes to the work. Well, take a couple more steps and clean it up, and we're pretty much done then. Multiply out the first part, that is x squared minus 10x plus 25. The second part, be very careful here. You have minus, supposedly 16i squared is equal to 0. And if you recall, I squared, that is the same thing as negative 1. So you really have x squared minus 10x plus 25. And then we have minus, and then that becomes a plus, and 16 is equal to 0. So our final answer is x squared, and then minus 10x, and then plus 41.